Imagine for a moment, are we truly alone in the universe? This cosmic question has puzzled humanity for centuries, sparking curiosity and fueling exploration. It's a question that probes into the very essence of our existence, our place in the cosmos, and the nature of life itself. It's an astounding thought to consider the vastness of the universe, a realm so immense it's almost beyond human comprehension. Consider this. There are billions upon billions of galaxies out there, each teeming with a multitude of stars, and swirling around these stars potentially are billions of planets. In the grand cosmic scheme, our own solar system is but a tiny speck. Yet, this seemingly infinite expanse begs the question, are we the only ones? The only life-bearing corner in this vast cosmic ocean? It's a thought that's both exhilarating and terrifying in equal measure. To wrestle with this question, astronomers and scientists use a mathematical tool known as the Drake equation. Named after Frank Drake, who first proposed it in 1961, this equation is not designed to give a definitive answer. Instead, it offers a way to estimate the probability of communicative civilizations existing elsewhere in the cosmos. The Drake equation takes into account factors such as the rate of star formation, the fraction of those stars that have planetary systems, the number of planets that could potentially support life, the fraction of planets where life actually develops, and the fraction of that life that develops into intelligent beings able to communicate across the cosmos. It's a fascinating concept, even if its results are speculative. But with such a vast number of stars and planets, even the most conservative estimates suggest that we are not alone. The question then isn't if life exists beyond Earth, but rather, where and how we can find it. The idea of life beyond Earth is not a new concept. Indeed, it's a notion that has captured the human imagination for millennia, with some of the earliest theories on the subject emerging from the minds of ancient Greeks. They were among the first to theorize about celestial entities, believing in the existence of other Earth-like worlds populated with life. This was a time when man looked up to the cosmos with wonder and awe, imagining a universe teeming with life. However, as we moved into the Middle Ages, the perspective shifted dramatically. The Earth-centered model of the universe, or the geocentric model, took precedence. This model, proposed by the Greek astronomer Ptolemy, placed our planet at the center of the cosmos. In this model, the heavens revolved around us, and the notion of life beyond Earth seemed less possible, if not outright heretical. But, as it's often the case with science, old theories were eventually challenged and replaced. The revolutionary theories of Nicholas Copernicus and Galileo Galilei brought back the possibility of life elsewhere. Copernicus, in the 16th century, proposed the heliocentric model, placing the Sun, not the Earth, at the center of our solar system. This was a radical shift in thinking, opening up the possibility for other worlds orbiting their own stars. Then came Galileo, who with his telescope, showed that these other worlds weren't just points of light but actual places. His observations of the moon's craters and mountains and the moons of Jupiter made it clear that the cosmos was far more complex and diverse than previously thought. This revelation reignited the speculation about the possibility of life existing beyond our home planet. So from the ancient Greeks' imaginations to the telescopic revelations of Galileo, our understanding of the universe has continually evolved. As our understanding of the universe expanded, so did our curiosity about what or who might be out there. This curiosity has fueled our quest for knowledge, a quest that continues to this day as we search for life beyond our solar system. In the modern era, our search for life has taken on new dimensions. With the advent of radio astronomy, we've been able to expand our cosmic reach, listening to the universe and its potential inhabitants like never before. One of the most significant developments in this field has been the initiation of the Search for Extraterrestrial Intelligence, or SETI project. This ambitious endeavor uses a vast network of radio antennas to scan the skies, searching for signals that might originate from intelligent life forms. SETI's mission is not just to find life, but to discover civilizations that may have evolved far beyond our own. In the summer of 1977, SETI made headlines with the infamous WOW signal. This strong, narrowband radio signal was detected by the Big Ear Radio Telescope at Ohio State University, an event that is still discussed and debated today. The signal, named for the WOW, written on the original printout, lasted for a full 72 seconds, and has never been detected again. Could it have been a transmission from a distant intelligent civilization? We may never know. Our search isn't just one-sided, though. We've made our own attempts to reach out to the cosmos. The Voyager Golden Records, affixed to both Voyager spacecrafts launched in the late 70s, carry sounds and images selected to portray the diversity of life and culture on Earth. These records, now floating in interstellar space, serve as a time capsule and an invitation to any civilization that may stumble upon them. However, despite these efforts, the cosmic silence remains unbroken. No definitive signs of extraterrestrial life or civilization have been found to date, but don't let that dampen your spirits. The universe is vast and our search is still young. Each day brings new discoveries and possibilities. While we have yet to make contact, our efforts continue, fueled by an insatiable curiosity. The quest for life beyond our planet, the desire to know we are not alone in the universe, is a quest that drives us forward. Our search is far from over. The last decade has been nothing short of revolutionary in our cosmic quest. In the vast expanse of the cosmos, the Kepler Space Telescope and its brethren have been diligently working, uncovering new worlds beyond our solar system. These exoplanets, as they're known, aren't just rocks floating aimlessly in space. Some of them reside in the Goldilocks zone, a region around a star where conditions may be just right. Not too hot, not too cold, for life as we know it to exist. Consider Kepler 186f, for instance, a tantalizing exoplanet located about 500 light-years away. It's the first Earth-sized planet found in the habitable zone of its star. Then there's Proxima Centauri b, the closest known exoplanet to us, orbiting in the habitable zone of our nearest stellar neighbor. These are just a couple of the over 4,000 exoplanets discovered so far, and who knows what secrets they hold? Meanwhile, closer to home, Mars and Venus have been making headlines. Recent missions to Mars have uncovered evidence of liquid water in its past, and perhaps even in its present. And let's not forget the exciting discovery of phosphine, a potential sign of life, in the harsh, acidic clouds of Venus. While these findings are intriguing, they're not definitive proof of life. But they have ignited a spark of hope and a flurry of scientific activity. As we speak, researchers are planning future missions to these planets. The Mars Sample Return mission, set to launch in the next few years, will bring back Martian soil and rocks for analysis. And Venus? Well, it's set to receive its first dedicated missions in over 30 years, courtesy of NASA and the European Space Agency. Every discovery, every mission, every piece of data brings us a step closer in our cosmic quest. We're piecing together the puzzle of our universe, uncovering its secrets one at a time. Every new discovery brings us one step closer to answering the age-old question: what does the future hold in our search for extraterrestrial life? As we delve deeper into the cosmos, we are armed with new tools that will revolutionize our search. Consider the James Webb Space Telescope, the successor to the Hubble. Set to launch in the near future, it is poised to become our most powerful window into the universe. Its advanced suite of instruments will allow us to peer further and with greater clarity than ever before. The James Webb Space Telescope will be able to detect the chemical fingerprints of water, methane, and possibly even the byproducts of life in the atmospheres of exoplanets. This could provide us with crucial clues about the potential for life as we know it. But our journey doesn't stop there. The dream of interstellar travel, once the stuff of science fiction, is slowly becoming a tangible possibility. There are projects in the works, like Breakthrough Starshot, aimed at sending lightweight, chip-sized spacecraft to our nearest stellar neighbors. These tiny explorers could travel at a fifth of the speed of light, reaching the nearest stars in just a few decades. This is a thrilling prospect. Imagine a future where we are not just a planetary species but an intergalactic one, where our reach extends to the farthest corners of the cosmos, driven by an insatiable curiosity and a desire to answer the most profound question: are we alone in the universe? As we continue to push the boundaries of our knowledge and technology, we can expect our understanding of the universe and our place in it to change. We might not know where this journey will take us, but one thing is for certain: we won't stop looking. We won't stop reaching for the stars. As we continue to gaze upon the stars, the question remains: are we alone? But perhaps soon, we might finally have an answer.